Hello all and welcome back. So in this video, let us continue our discussion and now let's do the last operation which is searching in our linked list. So we are going to start and do the searching by value. So given a particular value, I will have to return if that value is present or not, or better we can just return the index. So if the value will be there, we will return the index, something which we have been now doing a lot. So pretty sure we are comfortable with that. If not, then I have to just return the, let's say we are returning -1 as an identifier. Okay, great. So let us draw a linked list. And say this is none. Second. Great. So this is our linked list with 5 nodes. Now say I have to find value which is equals to 3. Now I know what different nodes are. So 0, 1, 2, 3, and 4. Right. So these are my nodes, everyone. Now to find this particular value, of course, we are gonna run a loop again, right? We have to start from head and check each and every node. If we are able to find that particular value, then we will just return the index. So we can have an index which is starting from 0. If we are able to find, then we can return index. If our loop due to some reason fails, then we just have to return. So it is very much similar to, I would say, linear search, right? It is similar to linear search, something which we have already done. Just that we are doing the same in a linked list this time. Now we all know linear search has a complexity of O of n. Here also complexity will be O of n, as we have to take worst case where either the element or the value is in the last, which in this case will be 5, or it is not present at all, right? So great everyone. Now let us try to code this then. Uh, 1 second. Yeah. So I have just actually added one thing here. This is our commons file. What I've done is I have created a new function, create linked list from list. Okay. So instead of entering the values, what I will be doing, I will be passing a list and just these values will be used. Okay. So just to save ourselves the pain of always entering the input, which is normally not feasible in many settings, right? On any, let's say in online compiler or somewhere, if we have some issues, I've just made sure that via list also my whole linked list can be created. Okay, so this is in my common.py. This is a file where now I have imported this particular functions. So just to check, we can have head create linked list from list 1, 2, 3, 4, 5. Okay, and let's say print ll head. If I run this, we are able to see. Let me run this again. So yes, we are able to see our output, right everyone? So this is the list which I sent and we are able to see the same. Great. So with that out, let us now try to write the code for search, right? So def search by value. We will be given the head of our linked list and the value. Great. With this, now again, we have to think a little bit, right? In our case, when we were doing linear search, we had the length of our array or list, right? Here we don't have that, but instead we have an identifier, and that identifier we know is that last is going to be none, right? As a good habit, again, we will not be using head, we will be making a copy, right? So that is something which we have been doing since long now. So instead of making head, I will be starting with a copy of head known as temp, right? So let us do that. Temp is equals to head. Index, I will take 0. So I will start from 0, keep on increasing it as I go to each and every index, right? So while my temp is not equals to none, this is the condition. I should first check. See, as of now, I have not checked for my head, for my first node. What if that is only equal to the data, the value which I'm looking for? So first I should check if temp.data is equals to value, then I should just return index, right? So this will be something of a base case in our recursive call as well. Not a base case, the work which we have to do, but I hope that in iteration as well, you are able to understand why am I doing this first. The reason, if I'm on the first node altogether, I have to check this. Then I think the work is pretty simple. Temp is equals to temp dot next and index plus equals 1. So I will be just now moving to each and every of this node. Index will keep on increasing, and if I'm able to find, then I should just make sure inside this line, inside this particular case, that I will return. If not, then maybe I can say not found. Okay, so pretty straightforward function. Let us just try it, everyone. I hope this is clear. Pretty straightforward. Just we are doing linear search in a linked list, right? So searching, and let's say print. I can just directly print it as well instead of catching it somewhere. So search by value. Let's say I'm giving the head and I'm giving the value as 3. Okay. So great, everyone. Let us now try to run this once. Let us clear this all. Okay, I think I zoomed in or something. 1 second. Okay, I mistakenly zoomed in. Wait, sorry. Let us clear this. Yeah. So yeah, let me run this file overall. We don't have to give any input now. So 1, 2, 3, 4, 5 is our linked list. Okay, and we are just printing. Let me just print linked list as well, so we can see the linked list in front of us. Great. So now if I run this, we are able to see 1, 2, 3, 4, 5 searching. Okay, I think we have not passed the value. My bad. Let us pass 3. See, it is able to give the 2 as an index. So 0, 1, 2. 2 is the index, right, everyone? Let us do 30. It is giving not found. Now let us just check for the boundary cases as well. So first is the one which is our head, the head which we have, right? We are able to see that head it is able to give. Okay. Next one, which we normally check on the tail. Yeah. See, it is able to give tail as well, right? So this is working fabulously well, everyone. Now, actually, we can write the recursive one as well. Maybe you can do the recursion the next time. So recursion is going to be a lot easy here. Search by value recursive. Okay, so it's going to be head and I'm going to give a value and say I'm doing it pass. So what you have to do now, everyone, you have to make sure that you complete this. Okay, it's going to be a lot easier, I believe. Now we have the base case, which we all know, head is none. We have the work which we will do. So it is almost very similar to that first index of a number also, the problem which we did in recursion, right? We used to first check and then we used to make the recursion call. So almost all the things are same. We can use another parameter index as well. I think with all this knowledge, you should be pretty nicely be able to write the code for this, right? And please just make sure that you are able to check on all these boundary cases in any online assessment, or say some website like LeetCode. Your code will fail for those boundary cases, so you will get to know about that. But in an interview, you are in a way required to find out them. Okay, so please have always the habit to think on the boundary cases while writing your code, not by running and checking them directly online, because then we have not thought of it, right? So that thought process, the one which is required to actually crack the interviews, to be a good coder, that will not get built up. Tomorrow when we will make some softwares, there also these kind of boundary cases occur, which we are able to then better think of. Okay, everyone. So I hope that is clear. Now let's meet in the next video. Thank you.